variable. So are you guys all with me here? Okay. You have two choices, and when you're doing these kinds, you're going to always have two choices. You can try to eliminate the x's, okay, or you can try to eliminate the y's first. And it doesn't matter what you choose to do. Sometimes you're going to have a little smaller number if you choose to do a smaller one. I'm going to choose the x's in the first example and then the y's in the second. So I'm trying to get these x's to have opposite coefficients. What could I multiply by? Ewan? I want these to be opposites. Opposite and exactly the same number. But that's not going to help me because this is a 3 and that's a 5.
Oh, negative. Wait.
What could we multiply this by and this by so that they would be opposites? They should be two different numbers. Yes. Can you make it -3? Very good. So if we multiplied the top by 5, wouldn't that be a 15x? And we multiply this by -3, wouldn't that be a -15x? If we added those together, wouldn't they cancel? But we have to do a whole row. So I'm going to do this whole row, what did you say, by 5, right? And I'm going to do this whole row by -3. All right, let's rewrite our new system. Now we have 15x plus, what's next? 25y equals 50. Very good. In the bottom, -15x minus 21y equals -30. Now what do I do with my two equations? Add them. So what do I get? 4y equals 20. Y equals 5. Now, this can be a little confusing because now we have these original two or the new two. It does not matter which one you use. I'm going to go back just to the original top equation, and I'm going to replace y with 5. So I'm going to do 3x plus 5 times 5 equals 10. Would you finish solving that for me? So I got x is -5. Okay. So this would be the ordered pair -5, 5. Okay. Let's move over to example 6. Okay. Now I want you to notice, what couldn't I do something similar? Couldn't I do something similar in this example if I wanted to eliminate the x's? I could do the top by 5 and the bottom by -3. But I'm just going to show you that you can also do the y's. And also, the nice thing about the y's is that they are already opposites. You could make one 48y and the other -48y. But actually, and you know what, if you did that, you would still get y correctly. And I mean x correctly. But couldn't you pick a smaller number that 8 and 6 both go into? No, 2 goes into them. I want 8 and 6 to both go into another. Not 16. Not 18. 24. Yeah. So, and also, do you know, see how one's positive, one's negative already? So, let's multiply the top by 3. Do you see how that's going to get me a 24y? And then what should I multiply the bottom by? 4. All right, let's rewrite our new system. We have 9x plus 24y equals what? 243. All right, and then in the bottom row, we have 20x minus 24y equals what? Well, think if you can, because it's 1 less than 40, Giuseppe. So it's like 4 times 40, subtract 4, because it's 1 less than that. So 4 times 40 is 160, and then because it's a 39, isn't that 1 less than 40? So then we'd take 160 minus 4, which is what? Yep, because that's kind of how you did the last one, right? Didn't you do 3 times 8 plus 3? Or 3 times 80? 3 times 80 plus 3? Or no? And then it's 3 times 8. So what is this? Negative what? 156. All right, let's keep going. Add them together. What is the resulting equation? 29x equals... Oh, hey, this is good. Let's do this, right? What's 13 minus 6? I'm doing the long way. Stop. 13 minus 5 is... This is what Charlie Comrie is doing. Well, he's doing long division right now. All right. What's 87 divided by 29? 3. Guys, there's too much extra. There's too much extra stuff. So what's my next step?
Plug in 3.
Plug in 3 for x. And I'm going to pick the top again. So I'm going to do 3 times 3 plus 8y equals 81. What's 3 times 3? 9. So I'm going to subtract 9 from both sides. I get 8y equals 72. Now what? Divide by 8. Y equals 9. The solution is 3, 9.